Yes, awesome. All right, cool. So let me get started by introducing myself. I am from Venezuela, by the way. I'm not from Mexico, but I live in Mexico. Uh, nice place to live here. By the way, I'm gonna be creating a breakout room for Q&A after this session, for 15 minutes after we finish. If you want to join there. I think you can download the presentation. I'm not entirely sure, Kathy. I'm sorry. So yeah, I have a bachelor's degree in physics and computer engineering, and I'm also a master. I did my master's in physics. I dedicated all my life, my academic life, to cosmology and astronomy. But I now work in data science, and I've been doing that for the past 7, 8 years. Uh, Mostly right now, I'm teaching. I'm teaching for several schools here in Mexico for UNAM and the Tecnológico de Monterrey. And also in the United States, I'm teaching for Berkeley, for Dartmouth, for Wharton, and Columbia. I have my own company. It's called Closter. And there I do consulting in data science. And also I am creating like a platform for teaching data science and all the things I'm doing. I'm very active on LinkedIn. So if you want to follow me there, you can see what I'm doing. I have a lot of videos there on LinkedIn and YouTube as well. So if you want to know more about what I'm doing, you can follow me there. I normally write a lot of articles. You can find me on Medium. I have like 130 articles published there. So you can find the article, read about several topics on deep learning and data science and AI. Cool. So I want to start this presentation by asking, how long have we been doing data science? Uh, you can also, if you want, like type in the chat, how long do you think we have been doing data science? 1 year, 10 years, 4 years, 100 years? What do you think about? I'm If someone wants to, 50 years, according to Luz, thank you. 2 years, according to Nico. Forever, according to Matthew. All right. 20 years, according to Leon or Leon. At least thousands of years. The phrase is what, 10 years old? 300 years. So a lot of different answers here. That's interesting because you can see that people are thinking in different ways. What is data science first, and how long we have been doing data science? So what I want to show you is not like the exact answer or the definite the answer of the question, but I created a timeline a while ago because I was asking myself the same question. I mean, how long does this world of data science been there? And so even though the start there is not exactly the beginning of data science, is one of the places that I think is when we really started on thinking about the idea on getting information, useful information out of past data to predict the future with computers in all of this. I know that science has been doing that for the past 400 years maybe, but I want to talk about the technological era, and that's why I am starting this timeline at 1943 with a great paper by McCulloch and Pitt for the neural networks. So if you see the timeline, you see very important topics there that I want to highlight right now. I'm not going to be able to talk about all of this timeline. You can find that on my Twitter account. It's at Favio Vaz, FAVIO VAC. You can find that there. And in there, you can also see my Twitter account and also my sister's account because she's the designer of my company, and she's helping me in all of the design for these slides as well and also this timeline. So let me go into more detail here. If you see now, I did like a zoom in the left part of the timeline, And now you can see in more detail some of the important pieces that were the beginning of data science and also data mining. That's going to be important very soon. So great papers to talk about. There is one about the the one called a business intelligence system by Loon. This is an amazing paper where he thinks in a way that a computer system can add intelligence to a business. And that's a lot of the things we're doing right now, because if you see and understand the idea and the like the and like what happened after the 50s is what is that we started using data to evolve in the different businesses um, areas, and also we thought about why can't we use all of this data we have right now to actually improve our processes as a business. So that was one of the first people who thought on the importance of using technology to improve and add intelligence to a business. But before that, there's two important papers. One by Turing, The Computer Machine and Intelligence, an amazing paper, and the other one is a theory of mathematical theory of communication, Claude Shannon. So these two papers were like the beginning of computer science. And one of the cool things that I like about the paper from Turing is that he really asks the question, can computers think? So back then in the 50s, he was not sure that we were able anytime to create like thinking machines, something like that. So he was not very close to the idea of AI or surpassing the intelligence of a human being. Now we think that we can do it. We're not entirely sure. We think we can do it, but it's interesting to see how one of the pioneers of computer science started to think about this back then in the 50s. Then we have an amazing paper by John Tukey. It's called The Future of Data Analysis. And for me, that is the actual start of data science, because that paper from Tukey, he realized, I mean, he was a statistician and he thought, I like statistics and I like mathematics, but I think now, and that's how he writes it, I think like I am more interested in the analysis of data. So kind of interesting because now he thinks that statistics is not his first problem. It's just he really wants to understand data as it is. So he created that topic of data analysis, and he thought and he proposes in that article that data analysis it's a science, and that is a science that means that for him data this new topic he was describing, the analysis, is not only to study data, but it's the scientific study of data. And that was one of the first people who really thought on this form of scientific field for the study that was uh, propagated through the future. And then we had important papers in the 2000s by Leo Bryman and also by William Cleveland and by um, uh, so William Cleveland, we have Jeff Wu, and we have Leo Bryman. And in from 97 to 2001, these people started to think about, hey, so data analysis has been there for a while. Statistics is very important. So maybe we need to create a new name for this field, and that was one of the first time someone said data science. By the way, Jeff Wu created a very controversial talk named "Statistics Equals Data Science," where he was asking to other people, to other academic people, that maybe data science is the way we should call statistics. That's not what happened, because we know now that data science contains statistics as one of the tools it uses for understand and analyze data. I mean, but we now understand that statistics and was like the father of all of these topics of data mining and data science. So data mining, important step in 96, we had an amazing paper by Fayad and Petesky Shapiro where they talked about the transformation of data mining into a knowledge discovery system in databases. So now it's not only to do data mining, but we now want to discover knowledge in databases. And those steps were really based on the ideas of Tukey. Were really based on the idea that data can be analyzed with a scientific field to understand it and also create knowledge and add value. Because most of the papers that came after the paper from Frayad and Shapiro on the 96 was about the actual application of data science in the business. So really interesting topic because that's how we understand now data science. So it's coming from statistics, then happened as data mining. And when we added more stuff, and I'm going to talk about what stuff we added, we now have data science. So if we go after 2001, there's a lot of things happening that I won't have the chance to cover. But I do have an article called The Roots of Data Science, and if you search online for the roots of data science, you can read more about this in detail, because in there I talked about like all of the beginnings of the field, the discussion, the problems people had, and how they created data science. So data science didn't happen out of nowhere. It's a process. It happened in a historical process, data mining, and now we have data science. So I'm going to stop here for the timeline right now, and I want to talk about what is the actual role of data science, because this is going to be very important. Because if we want to understand a methodology for data science, we need to understand what is its role. So the role of data science right now is to be the mediator of the path of using AI to impact businesses. And why I mean, this is not a definition of data science, it's just the role of data science. Because right now, we have all of these great people creating articles and papers on machine learning and advanced techniques for analytics and all of this. And data science takes care of extracting all of that knowledge and information and applying that to a business so we can improve the processes and actually be successful in the business. So you can think of data science as this mediator between the path of using AI and businesses. By the way, not everyone loves the term data science. Some people don't really like the word science there. But for the purpose of this talk, I'm gonna be defining data science as a science because it is helpful for us. Why is it helpful? Because if we have a science, we need to have a methodology for that science. So if we have a methodology, it's much easier to accomplish the tasks we want. And this is the same thing people did for data mining. And if you remember, there's great names like CRISP, DM, and KDD. Those were methodologies to apply machine learning and also data mining to add value to companies. So by the way, a lot of people are still using those methodologies. A lot of people, if you go to a company, they're still using CRISP DM to work and to develop their processes in data science. But there's a lot of things that happened between 96 and 2020. One of them was the creation of the team data science process by Microsoft, and then this whole idea of agile data science, like how can we add agility to data science. So I took all of that and I took one important paper and a methodology by Matt Dancho called the Business Science Problem Framework. And then I developed a new methodology based on three important things. First, we need to understand that this is a process of a process that has been happening historically. So we need to take into account the mining. So it's heavily based on CRISP DM, but it adds this topic of agility. And it also adds two more things. First, data operations, important topic that you should be learning about right now. And the other one is software engineering, how we create actual good code to be able to help a business without having a mess in the company. So this is how it looks like. This is the methodology that I am proposing that we should follow for data science. Again, it's not entirely new because a lot of these names you're seeing there are there for other methodologies. The idea is the combination now. We are going from data to value, and that's the idea of data science. We need to add value, and the value is not in creating models. The value is in actually deploying your models. If your models are all staying in your laptop and they're not reaching your final customers or internal customers, you're not doing anything. So we're going from business understanding, the same idea as in CRISP or others, data ingestion, data exploration, data preparation, modeling, benchmarking, that you need to try different models and improve your models, deployment, and monitoring. But all of these things, as you can see, are in a in a cycle of continuous development, of governed data and protected data. We have operations that are these unit tests, these continuous monitoring, and all of that. And also, we are thinking about that we should be versioning our code, our data, and our model. We have to be able to connect to platforms and to add continuous integration to data science, something that is missing for a lot of companies, continuous integration. So important topics that you should think about. Again, this is very fast. I only have 1 minute left. These are the profiles that I think that are very, very important for data science. As you see there, we have data scientists and data analysts and data engineers and DevOps people. We also will have data ops people, and there's people that we may don't think about, like the people from graphic design, people from UX. Those are very important people for data science as well. So what I want to do now is to I do have some slides left. I don't think I'll have the time to talk about them. Uh, but what I wanted to talk about is like this in like 10 seconds, and this is what's happening with data science right now. We have all of these IT people working, extracting the data from the knowledge. We have the business. And now we have all of these people from data science managers and data science, like the Center of Excellence, the CDOs, and they need to understand that they need a methodology to work. And this methodology is aimed to help them work in a better way. So I am going to be creating a breakout room for the ones who wants to ask any question in here. And I'm going to do that right now. So if you want to join there, thank you.